Hello. Now we're going to talk about solving a system of equations by graphing. But what's special about this is we're going to do it this time with word problems. So I've given you a couple of notes and hints here. When solving systems of equations contained in a word problem, the thing I need you to remember is that you're still looking for what point, given meaning the ordered pair, makes both equations true. The only difference between a word problem and a problem with no words is that the values of the variables in the ordered pairs have a real world meaning. So your process is the same, it's just that now you're going to have to say what the x value means and what the y value means. So here we have a process. Step 1, you need to write an equation for each line. Now I have a hint for you. When trying to decide how to write an equation for each line, look for two things happening at the same time. What I mean by that is if two people are doing the same thing, then you'll most likely need an equation for each person representing what each person did or is doing or has done. Or if the problem is talking about two different time frames, such as yesterday and today, or what I didn't write is, how about originally and next? So that's two different things, or two different time frames is a better way to say that. Or maybe this year and last year. You would need an equation to represent each time frame. The other real-world application you may face is the comparison of two companies. And a lot of times we use this when we're trying to decide in the business world something called break even, or where we're trying to do a cost analysis. Like, oh, it'll cost me more to go with this company if I only order so many of these, but it might cost me more if I order less. And then I compare it with another company, and where those lines cross is where the two costs are equal, but one company maybe cost me more when the other one costs me less, or vice versa. So we use this in the business world a lot. Then the next thing you do, since we're talking about graphing, is go ahead and graph it. So if the equation you wrote is in slope-intercept form, remember slope-intercept form is y equals mx plus b, graph the y-intercept first and then the slope. We did this in the S's. If the equation you wrote is in standard form, meaning ax plus by equals c, use the cover-up method to find the x-intercept and y-intercept and then graph. Remembering that when you cover x, then the ordered pair would be 0, y, and when you cover up the y, the ordered pair would be x, 0. Now I will also add a caveat here. This is not the only way you can do it. The other way you can do it is solve the equation for y, so that you end up with y equals mx plus b. So you end up with slope-intercept form, and that'll make things a lot easier to graph. So let's go ahead and start that now. Our first problem talks about Mrs. Haley. Well, Mrs. Haley is a dance teacher whose students are going to have a recital. She's comparing two companies' prices for filming the recital and producing DVDs. She's got Jessica's Productions, which charge $2 per DVD, plus $70 to come and film the recital. Then she's got Boonville Media, which charges $40 to film, plus $5 per DVD. To decide which company to use, Mrs. Haley determines the number of DVDs that would make the two options equivalent, meaning equal, in terms of cost. So basically, when do they cost the same? She wants to know how many DVDs would that be. So the first thing that I'm going to encourage you to do is take note. We just read it. Take note of what's going on. We've got two companies, right? We've got Jessica's Productions. And we've got, she charges $2 per DVD. So I'm going to do this. Jessica, she is charging $2 per DVD plus the $70 to come and film. And that would equal the total cost. And then you've got Boone Media. I'm going to put B for Boone Media. And they're charging $40 to film and $5 per DVD. And that equals their total cost. So we've got our two equations. Now we've got to graph this. So what I need you to think about is over here, notice how you have cost on your y-axis and DVDs on your x-axis. Now notice how I've set this up. I set it up according to what was on the x-axis, DVDs, what was on the y-axis, cost. Now, you could do this a couple of ways. You could set these two equal to each other and find out where they cross. That's one way you could do that. Or you could substitute what you see on the graph for DVDs and calculate the cost, and that would tell you where they cross. So I'm going to, I'll show you setting them equal on this one, and I think I'll show you on this problem down here what happens when we substitute. So I know at some point they're going to be equivalent, so they're going to be equal. So I've got 2D is equal, plus 70 is equal to 5D plus 40. Well, let's just solve. Minus 2D minus 2D. That's 70 is equal to 3D plus 40. I'm going to subtract 40 from both sides of the equations because I need to get the DVDs alone. So I've got 30 equals 3 times the DVDs. So divide by 3, divide by 3. The number of DVDs would be 10. So what I do now is I take the number of DVDs and I can substitute inside of either one of these equations to get the cost. So 2 times 10 plus 70 gives me the cost. Well, 2 times 10 is 20 plus 70 gives me the cost. Well, that would be 90. 20 plus 70 is 90 equals the cost. So here, when I write my ordered pair, I'm going to write my DVDs first, which is 10, and my cost second, which is 90. Now that's one way to do it. So what I'm going to do is I'm going to come over here and I have got to graph my first line. So notice my first line here starts at 70. So I'm going to go on up here to 70. That's my y-intercept. And what I know is at 10, which is right here, my output is 90. So I'm going to come up here and put my dot, oops, I put it in the wrong line, right here. Forget that. So that's what this first line would look like. I know how I can fix this. I'm going to say this is y equals 2D plus 70. That's that line. How about that? Now the second line, I'm going to do the same thing. I'm going to come down here to 40, which is my y-intercept. And I know again that at 10 DVDs, the cost is $90. So that dot is already there. So I'm just going to kind of do my best to put it here. And this line is y is equal to 5D plus 40, or cost is equal to that. So the question was how many DVDs would this be? Well, you would need 10 DVDs for the cost to be equal. So that's one way you could actually solve these. Now let's go ahead and take a look at our second situation here. We've got Mike and his cousin Olivia are picking apples in their grandparents' orchard. So we've got Mike and we've got Olivia. Mike has filled 15 baskets with apples and is filling them at a rate of 1 basket per hour. So here's Mike, and this is what Mike is doing. And then we've got Olivia has 5 full baskets and will continue picking at 2 baskets per hour. Okay, so here is our second situation or second equation. Once the cousins get to the point where they have filled the same number of baskets, meaning at some point these are going to be equal, they will carry them to the barn and then eat lunch. How much fruit will they have picked by then? Well, notice fruit is the y intercept. So we're going to now write our equation. So what we've got is Mike has already picked 15 baskets, and he's filling them at a rate of 1 basket per hour. And that equals the number of baskets. So if you're wondering where I'm getting these letters from, I'm taking them from the first letter of the x-axis and the y-axis. Then we've got Olivia. And what's Olivia doing? She's already got 5 full baskets, and she's filling her baskets at 2 baskets per hour. And that's going to give her her total baskets. Now remember I said we could do this 2 separate ways, and I showed you one way up here. Well, on this way, what I'm going to do is I'm just going to pick a value down here on the x-axis. Well, I'm going to pick 10 again. So I'm going to take Mike, and I'm going to say, okay, well, 1 basket per hour plus 15 gives me how many baskets? Well, 1 times 10 is 10, plus 15 is equal to so many baskets. Well, 25 baskets is what he will pick. Now, the ordered pair here then would be 10 for the hours, because that's what I put in, and 25 baskets. This is what he will have done. Now I'm going to come over here and I'm going to do the same thing for Olivia. So Olivia, she is doing 2, and I'm also going to use the same input, 10 hours plus 5 gives her how many baskets she's going to collect. So we have 2 times 10 is 20, plus 5 is equal to the number of baskets she picks total. So she's also picking 25 baskets, and that's what we wanted. So if they both work 10 hours, they will have picked, or they will have filled 25 baskets. So the question was, how much fruit will they have picked by then? They will have picked 25 baskets. Now for the graphing. We're going to come up here and we're going to graph Mike first, and he's starting at 15, which is right here. But remember, we used 10 as our input, and when we did use 10 as our input, we got 25 as our output. So this is Mike. So we're going to do y is equal to Mike is 1h plus 15. And then let's go ahead and graph Olivia. Well, Olivia starts at 5 baskets, way down here. And at 10 hours, she's also picked 25. So hers is going to be a little bit more steep. So hers would be y is equal to 2h plus 5. So that is how you approach a word problem. Guys, do not be afraid of them. It's just a matter of reading and understanding what you're reading and giving yourself clues and different tools to figure this out. So if you have any questions, please make sure you talk to me. Goodbye.